Alright, in a previous video I show you how do you make a more precise bell-shaped curve that you can see is also in the histogram, but this one is more precise because I'm using two summaries, the mean, the middle, and the standard deviation, which is how the data is spread out. And basically I did a number line, put a mark in the middle. That mark is going to be labeled as 74 because that's the mean, mean the middle. Sorry for the redundancy of the word mean. And then I put 3 marks to the right of the middle of 74 and 3 to the left. And I label those marks using the standard deviation of 9. So that means I'm counting by 9 every single time from one mark to the next one. So to the right of 74, we have 83, 92, and 101. I kept adding 9 to the right. The numbers I got to the left, 47, 56, and 65, I got them by subtracting 9 every single time. Okay, and we have a more accurate bell-shaped curve of this data, much more accurate than the histogram. Okay, now one of the things I can use this is to have an idea how my students perform overall in the test. And here's what I'm trying to say. I'm going to use something called the empirical rule. And the empirical rule tells me percent-wise how many of these numbers, of the numbers in the data set, are in between certain values of this bell-shaped curve. For example, the empirical rule says that anything that is one standard deviation to the right or to the left of the mean, which is the middle, okay, it's going to be 68% of the data is in there. Okay, so what exactly that means? Well, my middle is 74 because that's my mean. Oops, let me take my pencil here. That's my mean, my mu. Okay, the mean of the population. And I counted by 9 once to the right. That's the 83. That's one standard deviation. And I counted by 9 to the left of 74, which is 65. That's also one standard deviation. That symbol you see there, this symbol is called sigma. This is the symbol we use to label the standard deviation of the population. So any score that is, or any student, or any test score that is in between 65 and 83 is within one standard deviation from the middle. It's 1.9 from 74 going to the left and 1.9 from 74 going to the right. That's what we call one standard deviation because the standard deviation is 9. So that's what I'm going to write here, 1 sigma, one standard deviation. I counted by 9 one time to the right and one time to the left. 68% of all of these 17 numbers that I have here, okay, are between 65 and 83. And by the way, that's an estimate. That doesn't mean that's the exact value. So if I have 17 test scores, and I multiply 17 by 68%, 0.68. So around 12 of these 17 numbers are between 65 and 83. And again, that's just an estimate. That's not the exact value. Okay, so that's what I can use the empirical rule. So for example, if the dean asks me, hey Diaz, how your students did in that first test, I can tell her 68% of my students, around 12 out of the 17 of my students, they got a grade of in between 65 and 83. Okay, and I got that information by using this rule, the empirical rule. Now, when the data is 2 standard deviation from the middle, so 2 to the right and 2 to the left, we say that 95% of all of the data is in between there. So in my case, let me use a different color. So if I start in the middle and I count by 9 2 times to the right, I will get to 92. That will be 2 sigma, which means I counted by 2 9s. 2 standard deviation. So 2 to the right of 74, that will be 92, and 2 standard deviation to the left. So I'm going to count by 9 2 times to the left. That will be 56. Okay. So this is -2 standard deviation. Then the reason for negative means I'm going to the left, and I forgot to put the negative here too for the 1 sigma. So when you see negative, it means I'm counting to the left. So any data that is 2 standard deviation from 74, 2 nines to the right, 2 nines to the left, 95% of the data is going to be in there. Okay, 95%. So that's 2 standard deviation. Basically, what I'm saying is that if I take my calculator again, I have 17 scores. So 17 times 0.95, I get 16.15. So around 16 students out of the 17s that took this test, they earn a score of 56 and 92. And again, that's just an estimate. And the same thing will happen when I say 3 standard deviation from the middle. So if I count 3 not by 3 nines to the right, I will end in 101. Okay. And if I count from the middle, 74, 3 standard deviation to the left by 3 nines to the left, that will be 47. Okay. So 99.7%, this number you see here, is going to be within those values, 99.7 of all of these numbers. So basically almost all of these numbers are in between 47 and 101. And again, that's just an estimate. This rule is an estimate of how the data is distributed in this bell-shaped curve, and that gives me an idea of how my students are performing. Okay, that's the whole point of this rule.